Hi, this is the kit that RASA has been donating to some radio clubs in conjunction with the presentations that are being made this year. Inside this kit are a lot of ingredients for reducing interference in the shack, and I want to go over today what they are and how they can be used to reduce interference. It's full of items that are useful to take on site when you're tracking down interference at a given location. A great facility for a club and for its members to learn how to use it. There's a notepad for recording some information at the site. Some hand tools, side cutters and pliers, which are always handy. There's a kit of parts which consist of ferrite rings, clamp-on connectors, capacitors, chokes. There's even a compass in there, all of which is useful for eliminating noise around a shack. Also inside this kit is a plastic bag of cables and connectors, which when assembled forms a non-resonant DF loop used for tracking down the source of interference. It's very useful to try and locate the direction of where the noise is coming from, particularly at close quarters. Once completed, the coax loop will look like this one. It's very useful on both HF and VHF. It's non-resonant and can hook up to a handheld, and you can wander about with it to try and find the origins of noise. Instructions on how to assemble this loop antenna are on the website QRM.guru. There's a video which tells step by step on how to put it together. It doesn't take very long. At the back of this kit there's some documents which are also useful. There's a breakdown of the parts that are inside the kit with an image on the back of what they look like. There's a running sheet here for the radio shack. It's important to have a log of what you've experienced if you have to get someone from a power company or similar to try and help resolve your noise issue. It becomes part of the record. This is a diagnostic checklist which allows you to go through and tick off all the different parts about the interference. This is a log sheet which you can pass on to a neighbour if they're experiencing interference that they think is coming from you. They can record the times that the interference pops up, and later you can compare that to your own log and see if it lines up. The interference may not be coming from you at all. Lastly, we have a sheet here which can be sent to a power company if you're going to lodge a complaint about what you think is power line noise. You can write down your personal details and a brief description of the problem, and this can be the starting point for escalating the problem and taking it to the authorities. All of these forms are available for download on the QRM.guru website. So now it's time to open up this bag of parts and see what's in there and see how it can be used. There's a couple of large ferrite rings, and these are good when you are working with large diameter cables. There's a pair of smaller ones. We'll come back to that. We have some clamp-on ferrite devices in a couple of different sizes. These go around cables that you cannot feed through the larger connectors. Using a fingernail or a small screwdriver, you can unlock them, open them up, and put them around a power cable or something like that, just to stop the currents from flowing over the outside. Of course, there's a compass. It's a fairly simple one, but at least you can find out where north is, and that can help orient where the interference might be coming from. There's some mains filter capacitors here. These are rated to 275 volts AC, and are usually used in side equipment to stop transients from going into power lines, or between the power line connections and the earth. There's 5 of those in the kit. There's some low voltage filter capacitors, 4,700 microfarad, at 35 volts. These are good for automotive use where you have some interference coming from, say, a car alternator. Some smaller chokes, some low voltage polystyrene capacitors, green caps, also 0.1 microfarad. Great for audio situations. Here are some smaller clamp-on devices useful for smaller audio lines and those sorts of things. In this packet there's a couple of chokes. These kind of chokes are excellent for filtering out DC power supplies, for transceivers in cars where you've got ripple coming through, or even some RF feedback through the supply lines. And we have a couple of ferrite rods. You can just wind some wire around these and even put some heat shrink over them if you need to make a little filter on the fly. A lot of interference comes down to unwanted radio frequency signals flowing down cables and conductors where we don't want it to be. Sometimes it's feed lines and sometimes it is power rails. There's two distinct types of this form of interference. There's what's known as differential mode interference and there's common mode interference. To stop RF currents flowing down a cable that's experiencing common mode interference, the best bet is to use one of the larger ferrite rings or intermediate ferrite rings and put multiple turns around them. In this example, we can see an intermediate one where there was some interference to a telephone line. So these medium-sized rings are very good for telephone lines where the connector can pass through the ring multiple times and stop that common mode current flow down the telephone looking for an earth return and interfering with the received signal at the same time. These smaller 0.1 microfarad green cap capacitors are excellent for bypassing RF signals that are appearing on amplifiers and speakers. Putting one at the speaker terminals will help. Putting another one at the amplifier can also help. Even winding the speaker wire around a ferrite rod several times and then tying it off will make a big difference if you're getting noise into your amplifier. When it comes to interference coming along a DC power rail like alternator wind that's appearing in a motor vehicle, a pi filter can make a big difference. We've got a nice acrylic tabletop here, so I'll try and use it as a whiteboard and see how we go. So there's a ground potential, here's an alternator, and it's got an output going to a battery. There's the battery, and the other side of the battery is going to the ground of the vehicle. And then, as usual, we tap off the positive terminal of the battery and take it across to our radio. But here's where we have problems. On this active lead, there's going to be lots of ripple superimposed on the alternator, just from switching noise and even from voltage regulator noise from inside the alternator. And we've got to try and eliminate this because sometimes this ripple will come through the transmitted audio. So as we tap off the positive of the battery, we can have a filter capacitor, like one of those 4,700 microfarad capacitors we looked at earlier. Positive goes this way. We have our nice big series choke. And then we have another filter capacitor to earth. You can even repeat this through multiple stages. The trick is that this choke has to be able to handle the current that the transceiver is taking, and a lot of modern transceivers might take up to 10 amps just to try and get them going. So don't put too light a choke in there or you can burn it out. The ones that we've got in the kit are excellent for that. They would probably be good for most 50 watt VHF transceivers. So at this point here, it goes off to the positive of the radio. The electrolytic capacitors tend to bypass electrical noise to ground rather than passing it onto the radio, and the choke provides a high impedance path to that same ripple passing through. The net result is, after you've put the filter in, then it's nice and clean. So on this little diagram here, that's before filtering, and that's after filtering. And that's 12 volts there, relative to ground. The second type of interference where RF currents slow down conductors is known as differential mode. In differential mode, the RF currents are flowing down one conductor, passing through a load or a piece of equipment that you don't want it to, then returning on the second conductor back to the source. To try and deal with differential mode interference, the best bet is to use a filter where we're trying to remove those RF currents and bypass them without them reaching the piece of equipment that we want to protect. A good example of bypassing for common mode interference is in the power lines for this FT950 transceiver. If you just use it on its own, certainly if you're operating portable, it's not uncommon to have the RF out getting into your power leads, and suddenly you find your transmitter taking off when you're on sideband. As you hold the button down, the power output just goes to maximum and stays there, even though you're not saying anything, and that's RF feedback. It's a very strange thing, but it's fairly common with that transceiver and a lot of others like it. And the fix is quite simple. If you just take that power lead and wind it in and out of a large ferrite ring several times, that RF feedback won't come through the supply line. You won't experience that RF feedback, and suddenly the transmissions are clean again. It's a very small thing, but when you're experiencing it, it can be a very large problem on air. It's important to understand that these ingredients are just the starting point for tracking down interference for your club, to help members skill up and learn how to deal with these issues themselves. I would strongly suggest that the kit is kept topped up at all times, so if parts are used, they're replaced. Most of the ingredients are available through regular suppliers such as J-Car and Ultronics, and you may want to supplement that kit with other useful ingredients too. This is a very common little handheld, little T90, which is the general coverage receiver, great for taking around and finding out what's happening. You've got to be able to take photos. If you've got a phone, use that. You can also use it as an audio recording device. Or you can have a specialised audio recording device like this. These are very cheap now, that just record sounds to a little MP3 file on a card, and you treat it like a USB stick. If you can buy or create one of your own, an attenuator is a very useful addition. With this in series with the radio and the antenna, you can increase the attenuation of the signal as you get closer to the source, and that helps to track down where it's coming from. So I hope you found this useful. Please come and visit the QRM.Guru website, leave some comments and some experiences that you may have had in tracking down interference yourselves. It's a knowledge base that we want to add to over time, and it requires the assistance of all amateurs. If you go to the contact area of the website, you will see that there's an email address that can be used to post these comments. Thank you.